Hello, my name is Anna. I'm a high school junior in San Francisco, and I'll be conducting this interview on behalf of Humans of Neuroscience, an initiative in the Simply Neuroscience organization dedicated to sharing the stories of different people involved in neuroscience and psychology. So to start, would you like to briefly introduce yourself?
Sure. Hi, my name is Srija. I currently live in San Diego. I graduated from UCSD. Currently, I work for UCSD in the neurosciences department under a couple labs, working on various projects with neurodevelopmental disorders and also neurodegenerative disorders. So we'll probably talk more about that later, but a little bit about what I do is more like wet lab research. And my future goals are to hopefully attend med school in the next year or so. So that's like kind of my trajectory. But yeah.
Yeah. So to start at the very beginning of
Mhm.
chronological, I guess, how did you first become interested in neuroscience?
Yeah, so that was more at the end of high school. I was applying as one does for undergraduate degrees. And I had actually been more interested in biomedical engineering. So I was applying biomedical engineering and I happened to select neurobiology as a second choice major at UCSD. And when I got in for UCSD, I got in for that major, not my first choice. And I realized that's actually something I really wanted to do more than some of the schools that I got in for BME. So I ended up choosing UCSD and neurobiology. And then I got involved with research on campus. Through the classes I was taking, I was learning some concepts, and I realized I wanted to learn more about them, more in a practical and applicable way instead of just on like a online course or a textbook or something like that. So I asked around and I found a couple of professors that I was interested in their research, but eventually I ended up emailing this one associate professor, and he said he had space for me in his lab. So they focused on Alzheimer's research, more like neurodegenerative research, memory, learning, those kind of things.
Yeah, that's really cool. How did that
Mhm.
first initial interest lead you to what you do today with what kind of work do you do and maybe why you're interested in that kind of work specifically?
Mhm. So I'll start with the how it led to where I am today. That PI, that principal investigator, so that's kind of the boss of a lab. That PI referred me to the PI I currently work for, Dr. Rowe. And their research is somewhat like what do you call it, overlapped. And I also got introduced to another PI that I work for, Dr. Campbell, all at UCSD. These three PIs have various focuses in neurobiology and neurosciences. So that's how I kind of got into the position that I am today. What I currently work on for Dr. Rowe is epilepsy research. I'm doing video EEG techniques, working with animals, mainly mice, only mice. And we do several video EEG techniques like surgery, inducing pilocarpine, which is like how you structure a mouse model, like you induce seizures in that mouse model with this technique. It's like a chemical drug that we give to simulate human epilepsy after traumatic brain injuries like car accidents or sports injuries, things like that. And we also have various mouse lines to kind of simulate the inherent epilepsy, like things that you're born with. So those are like things that I do under Dr. Rowe. And then under Dr. Strawman, which is the first PI that I first got introduced to in undergrad, I am following a project that has shown some promising results following a supplement that has shown to reduce seizures in the pilocarpine mouse model. And then under Dr. Campbell, I'm looking at more autism based molecular biology, looking at various proteins and their involvement in neurodevelopmental pathways, and looking at if you alter those concentrations or like if you alter the amounts of protein that are in yes, not in an animal or in a human, more like cellular examples, cellular models. If we alter those protein levels, what does that do to the final structure or final result for that neurodevelopmental pathway? So that's kind of what I do. I know that was a lot of words, but yeah, does that kind of make sense?
Yeah, that makes sense.
Okay, great.
Would you say in getting to where you are right now with researching a lot, what were maybe different obstacles that you faced in getting here, like whether internal, external, whatever?
I think I didn't personally experience this, but I know a lot of people do when they're first getting into the field or getting into research in general. It might be hard to find a PI that is willing to take you on. I was really lucky in that sense. The first person I emailed was Dr. Strumman, and he took me out. But I know that that's not a general case. Like it's not very common. So it's sometimes hard to find someone that's willing to take the time to teach you. Um, to them, I just say be persistent. Like, look, that's like the first obstacle, trying to get into the field itself. And then once you're in the field, obviously, this is not a very easy field or a well established field. Like, neuroscience in general is well known, but there's a lot of things in neuroscience that we don't know. It's like a very, very vast field, and we're barely touching like the tip of the iceberg, right? So that it can get frustrating sometimes not having any precedents. A lot of fields have a lot of papers that cite like various topics that people are researching, but for us, sometimes it's a little bit more difficult, especially when you're researching something very, very new and novel. So that can be a little bit difficult. And then, as with any research, it can be difficult to produce results that actually matter and actually like show what you want to show. There will be 10 failed experiments behind the one successful experiment. So that's another thing, but that applies to research in general. It's just you have to keep pushing and pushing and really, really love what you do to like be able to do this. Yeah.
Yeah. Yeah, that makes sense. On the more like positive side of research,
Mhm.
what is like maybe one of your favorite research projects you've worked on or topic?
So I think I love all of my research equally. But the most recent project that I worked on, I'm presenting an abstract at AES, a conference in LA. It's going to be in December sometime. It's called the American Epilepsy Society. I'm going to be presenting an abstract on that project I was talking about earlier under Dr. Strawman. It's like a project looking at the efficacy of a supplement that's available over the counter at preventing seizures. So we found some convincing evidence through video EEG techniques of the pilocarpine model that this supplement does help reduce seizures in this model. So I'm really excited to be presenting that because there is a lot of room for expansion on that project. We're just barely like starting, so it's really nice. That's something I'm really excited about.
Yeah, that's really cool.
Mhm.
What would you say like about the brain still really fascinates you and what are like one of the biggest mysteries you like find yourself drawn into for in neuroscience?
So there's a lot about the brain that we don't know, and there's a lot of mysteries. I think the biggest one for me currently is because of where I am, like what I'm doing right now in epilepsy or in the field of epilepsy. A lot of doctors see patients and they prescribe various different treatments or medications. Only I guess one third of patients don't respond to any medication, like no matter what combination, what type of thing. And one third of the patients with epilepsy is a huge number if you think clinically. Like two out of three people walk away fine, but one person out of every three people does not, it doesn't work for them. So my goal in kind of researching this supplement too is to maybe see if we can treat that one third of people. Um, and it's fascinating because they can have the same type of epilepsy, they can have the same type of frequency, and they can respond so differently. So I think that's something that fascinates me about the brain. Like everyone is different. Everyone has minor like differences that change the way medications help them or hurt them, change the way their disease progresses. So I think that's something really unique. Everything is very, very particular, and you have to be very meticulous with like treatment plans and everything. So that's something that fascinates me. And that's why I'm even more excited about my project and all the projects that I'm doing.
Yeah, that's really cool because like I know like one of the biggest things in neuroscience is how different everyone's brains are. So it's interesting to see that how that reflects in like a clinical setting. So that's
Hmm.
really cool. You said that like you want to apply to med school in the future. What
Hmm.
would you like to like would you like to say what draws you to the like clinical setting specifically?
Um, I guess I always wanted to be in a clinical setting. I also really enjoy research, but I didn't know that in the beginning. But I always knew I wanted to end up in the clinical setting and have research adjacent to that so that I could like, further medical practices with research on the side. Um, Specifically speaking, there have been a couple of experiences that I've participated in. I was an EMT for a little while, and I had a lot of interactions with patients around San Diego County, and that was very inspiring. I realized that that was what I wanted to do. I wanted to be a physician that could help people. And then I also volunteered at a local children's hospital in the emergency department. And we had a lot of neurological concerts because children are always falling and hitting their head. And sometimes it was just because of a headache, or sometimes it was because of a fall, you know? And that kind of inspired me. Like, I wanted to work with kids, I wanted to work in neurology. And that kind of draws you to the field of epilepsy and autism and all these focuses that I'm kind of trying to research right now. So that's how it all ties in.
Yeah, that makes sense. You said you worked as an EMT. What is that exactly?
Oh, an EMT is an emergency medical technician. So in the emergency field, you have emergent calls like the 911 calls. You also have interfacility transport. So between hospitals or between medical facilities, you have transporting of patients, and that is what I did. EMT, we're called
Mhm.
BLS, so basic life services. 911 is ALS, advanced life services. So I basically helped patients and tracked their healthcare through different medical facilities. So this could be anywhere from one ER to another ER, a more advanced hospital to a skilled nursing facility, or a basic hospital that needed to elevate the case to a more advanced hospital. So basically, any transport between any medical facility, I was in charge of my patient along with the partner. Generally, we took turns. One person was driving the ambulance, and then one was sitting back with the patient. Responsibilities included taking a full medical history, taking vitals, making sure that you convey this information properly to medical healthcare professionals, either, and also getting the health information from medical professionals as well. So yeah.
Yeah, it's really cool how you've had like both experiences of like clinical and research, and they're both really
Mhm.
interesting. Yeah. And then kind of to end, what advice would you give to younger students that want to pursue neuroscience?
Um, Definitely explore as much as you can. There are so many resources within your household. You have the internet. There are several papers published yearly on big neuroscience journals, like the Neuron, Neuroscience, and Nature even has a couple of neurology journals. And there is so much exploring you can do like just online. Like just look up different diseases that interest you, different mechanisms that interest you. And then of course, when you get to a setting where you can participate in research, like undergraduate colleges or institutions that are near you, private or public, that allow for younger children or younger students to participate, I would definitely take advantage of those. I think the biggest thing you can do before you even step into the world of research is to research, research, research. Like research what you want to do, research what you want to study. Just look up all these papers and gain a lot of background knowledge as much as you can. And then of course, if you plan on majoring in neurobiology or neuroscience in college, that will definitely like help even with your major, just like reading these papers, you know. There's a lot of literature already out there. Talk to mentors, talk to like anyone that you can get your hands on, like family, friends, or like your PCP, your primary care provider. Like ask them about opportunities, ask them about how their pathway was, you know, because they likely had a training in neurology, even though they might not be specialized in neurology, you know. And I believe all students of any age can shadow physicians. So if you want to shadow a pediatric neurologist or a neurosurgeon or something like that, you can check. There are some restrictions after COVID. I think they've been tightening on those, but you can also shadow physicians or shadow, you know, scientists. I think you can do the same thing for PhD candidates and also PIs in research. So you take use of those opportunities. Look up schools near you, graduate institutions, or hospitals, and see if you can shadow them as well.
Yeah, thank you. So that concludes the interview for today. Thank you so much for speaking about yourself and neuroscience. It was all really interesting.
Of course.